Recorder is rolling for part two here. Okay, so you guys went back to the lab area. You guys did one of these four experiments, depending on which group you're in. And you also made either one or two graphs, depending on which one of these you had, and also did one of these write-ups. So here's what we're going to do. I'm going to go over one of the AP style solutions to actually specifically going to do displacement versus time or distance versus time. I'm going over this one, which I know only a couple of you guys had this one. Okay. Then after I go over that, because I want to walk you guys through what an AP style write-up would look like. Okay. Then after I go through that one, I'll pass around these so that you guys can grade yourselves and see like exactly what you did versus what AP probably would have been looking for. And then after that, we'll go over the graphs and I'll pull up an Excel page. You guys can see that too. Okay, so I know some of you guys had this one. So you did different rolling distances and you timed how long did it take to go different distances. Okay. Now, what would have been the ideal AP right after that? Okay. So the question is, what's the relationship between distance and time for a car to roll down an incline? Okay. And you're controlling the mass of the angle. So I'm saying constant mass, constant angle. Okay. Oh, please zoom in here. Go a little better. Okay. Measuring tools. Okay. Well, you needed either a scale or a triple beam balance. Didn't have to mention both, just one of those. Okay. Meter stick would have been good. I guess we said ruler that could have worked also, but or actually you guys just use the built-in meter stick on the inclines. That's fine. Mention meter stick. Mention either a stopwatch or a timer, and also a protractor, just so you can grab the angles. You know, same thing as the triple beam balance. Okay. I guess the really important tools here were meter stick and stopwatch, right? Meter stick, stopwatch to get the right. Right. And the other ones just so you could have controlled variables. Right. Data gathering procedure, which is how to measure what variables using what affirmation tools. Okay. So usually you want to briefly mention the setup. So set up an incline at a shallow angle above the horizontal for the toy car to roll down. Now, I forgot to mention, you guys see some colored pencils on your desk? See some colored pencils? So everybody grab one of the colored pencils. I'm going to have you guys grade yourselves. Obviously, the exact solution I'm going over right now only applies to two groups, but later on I'll pass it to the ones around. Okay, so I made all the points add up to 12 because this is like a 12-point FRQ. So, you know, sometimes they give a point for describing the setup and sometimes not, just depending on how 12 points can be distributed. Okay. Use the protractor to measure the angle of incline to the horizontal. Notice not specifying the angle with respect to what, right? Because is it with respect to the vertical or with respect to the horizontal? In this case, it's with respect to the horizontal. So 1 point for mentioning that. Alternative, you know what I didn't put down here that could have worked perfectly well too? If you measured if you looked at this as a right triangle and you measured two of these things, the height change, the length change, or the ramp, the incline length, and then did some kind of inverse trig function, you could have calculated the angle that way. You should have gotten either 5 degrees or maybe 4 degrees, right? So 4 or 5 degrees. Okay? I got like 4.7, 4.8 earlier. So that's 1 point for mentioning the application of the protractor. Use the triple beam balance to measure the mass of the car. So 1 point, so record that value. So 1 point for mentioning application of triple beam balance. Okay. With the meter stick, establish a 200 centimeter rolling distance. So 1 point for application of the meter stick. Release the car from rest, starting from the top of the incline, and use a stopwatch to measure how much time it took to travel to the bottom of the incline, to that 200 centimeter distance. 1 point for mentioning the application of stopwatch. Repeat this step 2 more times and take an average. This is always a point. Right? This will pick you up 1 of your points. By the way, side note here, half the AP exam is multiple choice, half of it, 5 FRQs collectively. This is a 12-point FRQ. If you add up all the points you need to pass, here, have you guys guess? How many points do you think you need all together? Multiple choice plus all the FRQ questions. How many points do you think you need to pass?
How many points are there total?
There's a little bit short of 100, and they change it every year a little bit. It's like 90-some points. What do you think? Ooh, 50 is a good guess. It's not even that many. What do you think? Ooh, 40 is pretty close, but not even quite that many. 35, so you got it, about 35. Actually, that'll put you right on the edge of passing. And this is always one of the points, is to do multiple trials and take an average. And you want to say to reduce random error, okay? To reduce error. That's it. That's all you need to pass. But really? Yes, somehow that ends up being really hard to beat. So I've never had the majority of students pass. So but maybe this is the year because you guys know this is a tough exam. No. Change the rolling distance to 180 centimeters and repeat steps 5 and 6. Do this for 5 different rolling distances. So you guys see how distance or displacement, either one you called it, could be the independent variable, right? Sometimes that's a point. In this case, it didn't add up to 12. So, right. Then this continues. Oh, okay. No, that's all. That's all you need for data gathering procedure, right? See how that's pretty straightforward. Use this, we'll measure this. Use this, we'll measure this. Change this variable. Boom, done. Okay. Then data analysis. You could plot distance versus time, and I'll pull up an Excel table here in a moment and have some of you guys share your data. We'll plug in and see exactly what that graph should look like. Now, distance versus time. What do you think that graph look? Or actually, some of you guys should know because you have it right in front of you. What shape did that take? Was that a linear graph? No. What shape was it? Kind of curvy. And if you had to guess what kind of curvy shape that was, parabola. This should have been a parabolic graph, okay? Because this, I have it right here. Parabolic linearize the graph by graphing distance versus time squared. Okay. Oh, you know what I should have said too? See how I said distance versus time, and then later on distance versus time squared? So I got a really good question I forgot to mention earlier. What normally goes on which axis? Like which normally goes on the horizontal axis? Independent or dependent variable? Independent variable. Right now, so there's rules for what goes on which axis, right? Almost all the time, independent goes on the horizontal axis. There is an exception to that rule. Whenever you're counting how much time is taking, tick, 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 then that rule replaces the other rule. And you always put time on the horizontal axis. It's just a convention people come up with. Right? So that's why I have distance versus time. Okay? And then distance versus time squared. That should linearize the graph. So 1 point for linearizing the graph, distance versus time squared. 1 point for saying there's a parabolic relationship between just plain distance and time, whether you did meters or centimeters, right? I've got extra detail down here. The notes I'm going to give you guys over the next couple of days, we might get to this today because we have a really long class today. We might get to this detail. It turns out that the slope of this graph, and you would have, actually, if you're asked this stuff RQ in May, you would be expected by this point to be able to figure this out, but you'll see this later, right? It turns out that the slope of distance versus time squared, right, which is linear, right, turns out to be half the acceleration. Acceleration is the rate that speed is picking up. Okay, so that won't make sense right now, but later on, as the class goes on, that'll eventually make sense. Okay, conclusion: distance of the car rolls is directly proportional to, let's say, you could linearize the square of the time to roll. Okay? So if you do distance versus time squared, then you should get a linear relationship. Okay? And that's the conclusion you can draw. Even better if you can make that an equation. X equals something t squared. So suppose you did make that an equation. What would that equation look like? Because I thought some of you guys have like some kind of number, t squared. Okay? Now I'm just going to make up a number just as an example right now. Suppose you come up with, does anybody have an answer for this? Okay, here, I'm just going to make up something crazy. Let's say you came up with like 5.04. I don't know, just something crazy, right? Now, do you think you need units that are attached to that number? And what would these units be? Suppose, I'm just going to make up some. Suppose you went with centimeters per distance. Suppose you went with seconds per time. Okay. What would the units on that 5.04 number be? There's only one unit that makes it consistent. Centimeters per second squared, right? Because whatever time, suppose you plug in with 1 second, right? That'd be 1 square second. Now you're dividing out those square seconds and you're multiplying in centimeters to give you centimeters. And how that would work? So you should either have meters per second squared or centimeters per second squared if you have this exact lab. Okay, you guys got that so far? Okay, so here's what I do. I'm gonna stop this video. I'm gonna pass you guys out all your individual points rubrics, and I'm gonna have you guys grade yourselves. In the meantime, I'm gonna pull up an Excel page and put together the graphs with you guys.